Hi, thanks for watching this video. This is Mr. Bowman, and in this video we're going to share with you factoring trinomials. Okay, so we've been talking about factoring for a little while now, and just as a reminder, what does it mean to factor something? Well, to factor something means to write it as a product, as a multiplication problem. So if I wanted to factor 15 and write it as a multiplication problem, one way to do that would be to write 15 as 3 times 5. And of course, it's not the only way to do it. You could write it as 1 times 15 or 7.5 times 2, but that's a factorization of 15. If I wanted to factor the monomial 24x cubed y, you know, in my classroom before we social distanced for the rest of the year, we practiced that skill of factoring a monomial like this when we were finding square roots of monomials. So one way to factor 24x cubed y is to write what we called its total prime factorization, or its total factorization. 24 could be written as 2 times 2 times 2 times 3. X cubed is x times x times x. And you know, this actually shouldn't say y times y, should it? That should just say y. There we go. So how can I write this trinomial, x squared plus 7x plus 10, in factored form? Well, we don't know that yet. That's the point of this video. That's what we're going to work on today. I'll show you an example of how this works, and I'll remind you of one way that you can multiply polynomials, which is a way that we used in our classroom earlier in the school year, which was to use a box setup. Factoring essentially is asking you to write the expression you're given as a multiplication problem. So earlier in the school year, we would multiply polynomials together, 2-term by 2-term polynomials. And we would get trinomial answers like x squared plus 11x plus 24. So what I'm looking for if I want to factor this is an expression whose answer is x squared plus 11x plus 24. And what I remember from the work we did earlier in the school year is that my x squared always appeared here in the upper left box. These two here, these two boxes here, would add up to equaling positive 11x, and then I would get a positive 24 here. So let's see if we can use what we know to figure out what the 4 terms that we need, 2 terms and 2 terms, are. You know, one thing I'm pretty comfortable saying is that I know what to multiply to get x squared. It would be an x here and another x here. But to figure out what 2 numbers go here and here, I need to figure out what 2 numbers I could multiply to get 24 that would also add up to give me 11. So let me maybe list out some of the things I know that multiply to give me 24. I could use 1 and 24. I could use 2 and 12. I could use 3 and 8. I could use 4 and 6. Can you figure out which one of those would add up to 11? Yeah, it's this one. And that tells me what 2 numbers need to be the second part of each of those binomials. It doesn't matter which one you put where. I'll put positive 3 here and positive 8 here. And what would be worth doing now is to make sure that that does in fact get me the 11x that I'm looking for. X times 8 is 8x. 3 times x is 3x. Do these two add up to 11x? They do. We've got it. This and this multiplied together will be the factorization I need. I'm looking for x plus 3 times x plus 8. That's it. If I want to check that, I can multiply those together, and the great thing about using the box to factor is the work you would do to multiply them together is already there. It works. Let's look at another one together. Let's see if we can factor n squared minus 13n plus 30. And again, I'll use the box. So I know from experience that my n squared goes here, and that I need positive 30 here. And I think I know what to multiply together to get n squared. It's going to be n and n. I need to think about what two numbers I can multiply together to get 30 that would add up to negative 13. So for 30, I've got the options of 1 and 30. I've got 2 and 15. I've got 3 and 10. I've got, not 4, but 5 and 6. Do you see which pair of those would add up to negative 13? Kind of, right? These would add up to 13. How could I make them negative 13? What if I made them both negative? What if I did negative 3 and negative 10? And the reason that's okay here is that when I multiply negative 3 by negative 10, I still get positive 30 as my product. So negative 10n here and negative 3n here does in fact add up to negative 13. We've got our answer. We need n minus 3 times n minus 10. Let's look at one more example together. Let's factor x squared minus 2x minus 48. I know that x squared belongs here. I know that the negative 48 belongs here. And I even know how to split up x squared into x and x. I want to think about the factors of 48, and there's a lot of them. There's 1 and 48. There's 2 and 24. There's 3 and 16. There's 4 and 12. There's 6 and 8. Now the fact that I'm going to get a negative 48 here means that my signs need to be different. So what I really need to find is the two numbers that subtract to 2, which is this pair here. I need the 6 and the 8. And I need one of them to be negative. Can I figure out which one to be negative to make it negative 2? It's this one. I need negative 8x and positive 6x. Those do add up to negative 2x. So I've got x plus 6 times x minus 8. Thanks for watching.